Hey guys, today we are looking at graphing sine and cosine functions on an XY axis. If you don't have a unit circle out next to you, or if you don't have those memorized, I would pause the video and get one out right now so you can keep up with putting these values in the table. So the first thing we're going to do is graph f of theta equals the cosine of theta. So what that means is theta is our input, it's our x values. And then the cosine of theta is our y values. So we want to look at our unit circle and see what our output value is when we input that certain degree number, or in this case we're going to be working in radians. So at 0, we are over on the right on the x-axis, and so that point is 1 for cosine of 0 is 1. At pi over 2, we're at 0. At pi, we're at negative 1. At 3 pi over 2, we're at 0 again. And at 2 pi, our cosine of 2 pi is 1. We're right back to that starting spot. So when we go to graph this, we are going to plot on our x-axis. Obviously this is 0, the origin, but I'm going to plot every pi over 2. And I kind of space it out the best I can. And then I can even go backwards and do negative pi over 2. We can keep going with this past 2 pi. So we could go to 5 pi over 2. This graph will go on forever. So what that means is then our domain has no restrictions. So negative infinity to infinity. So when I start to plot this at 0, I'm up at 1. And then negative 1 looks to be the other value I need there. So at 0, I'm up at 1. At pi over 2, I'm at 0. At pi, I'm at negative 1. 3 pi over 2, I'm back to 0. 2 pi, I am back up at 1. So if you connect these, they don't connect in a straight line. It kind of looks like an absolute value right now, but it actually is a curve if you found some of those values in between. And it looks like this. And I said we could keep going, so if you look at how this curve is patterned, at 5 pi over 2, that's the same as at pi over 2, so we're coming back down here. And then at negative pi over 2, again, we're back down at 0. So that's what this looks like, and it just keeps going. It follows this curve forever and ever. So, but if we're looking just at 0 to 2 pi, you'll notice that we start at 1 and we end at 1. We have negative 1 in the middle. So it's kind of a valley that we're looking at there. So then our range, the lowest we ever go is negative 1. The highest we ever go is 1. So negative 1 to 1 is our range here. Period is how long it takes to complete one cycle. So for the cosine of theta, when we start up at 1, we go all the way down and then back up to 2 pi. That is one cycle. So our period is 2 pi. And then our amplitude is how high or low off the graph are we going? So we are going an amplitude of 1 in either direction. Alright, graph of sine theta, you're going to see is similar, but has its differences. So again, we're looking at theta is our input and sine of theta is our output. We'll start at 1 here, or we'll start at 0 here, and then pi over 2, and pi, and 3 pi over 2, and 2 pi. So the sine of 0 is just 0. Up at the top of the graph, pi over 2 is 1. At pi, we're back at 0. At 3 pi over 2, we're down to -1. And at 2 pi, we have hit 0 again. So when I go to plot this one, I'm going to do exactly the same thing. So I'll put pi over 2, pi, 3 pi over 2, 2 pi, and I could continue that graph as well, just like I did in either direction. Looks like we're still at 1 and -1. So this time, instead of starting up at 1, though, our sine graph starts at 0, 0. At pi over 2, we have gone up to 1. Pi, we're back to 0. Down to -1. And then we start the cycle over again at 2 pi. So we're at 0, and then the next one would be up at 1. So again, that should tell you that your period for this is also 2 pi. This goes on and on forever in both directions, so -infinity to infinity, but we don't go above or below -1 and 1. So again, very similar to the cosine graph. Amplitude, just like cosine, goes up 1 or down 1, so we have an amplitude of 1. All right, so those are kind of our parent function graphs. Those are our parent function graphs. And then we can change these just like we've been doing all year long. So we can put some a value out front of the sine or the cosine, and then some b value in front of that theta value or x. So when a and b are not 0, the amplitude is just a. So whatever number is in front of sine or cosine is going to be the amplitude, how high or low off the graph that we go. And then the period is 2 pi over that b value, so the number inside the x there. All right, so when we're graphing when we are not in that standard parent function, the first two things you want to look for are the amplitude and the period. So amplitude is that number in front, so it's going to be 2. So we know that on our graph we're going to go up to 2 and down to -2. And then the period is 2 pi over the number in front of x. So 2 pi over 4, which reduces to pi over 2. Okay, so what the period tells you is that is the point where it has completed the cycle one time. So we're going to start at 0 and end at pi over 2. So what I like to do on the graph is if I'm starting at 0, I'm ending at pi over 2. I cut it in half. So half of pi over 2 is pi over 4. Half of pi over 4 is pi over 8. And then I'm counting by pi over 8 to get to this last value. So 1 pi over 8, 2 pi over 8 is pi over 4, 3 pi over 8. So those are our values that belong in this table. So pi over 8, pi over 4, 3 pi over 8, and then pi over 2. Now, we talked about sine starts at 0. So from 0, then our sine goes all the way, so 0, 0 is our first point. But then our next one, it looks exactly the same except our amplitude has changed. So it goes all the way up to the top, to 2. So pi over 8, we're going to be at 2. And then it comes back down to 0. So at pi over 4, we're back at 0. And then we know that our sine graph goes down to the bottom. So at 3 pi over 8, we're down to -2. And then we have completed one period, and we're back to 0 at pi over 2. So the graph shape still looks the same. We just are changing the values on the x and the y axis to match what is in our equation. All right, so let's try another one. Now we have a cosine graph. So amplitude here is going to be 1/2. And then period is 2 pi over 1/2. 2 pi divided by 1/2 is the same as 2 pi times 2, so we get 4 pi is our period. So that means I'm going to go up 1/2 and down to -1/2, and then I'm going to end at 4 pi. So I'm going to cut that in half, 2 pi. I'm going to cut that in half, 1 pi, and then 1, 2, 3 pi. Okay, remember that your cosine graph started up at the top at 0, and then it makes this valley. So at pi we're at 0, at 2 pi we're at -1/2, at 3 pi we're back to 0, and at 4 pi we have completed one period, so we're back to where we started. So you can draw your XY chart. So 0, we're at 1/2. At pi, we're at 0. At 2 pi, we're at -1/2. 3 pi, back to 0. And finally 4 pi takes us back up to 1/2. Alright guys, that is all we have for today. So if you have any questions about graphing sine and cosine functions, feel free to come in and see me. Otherwise, I will see you in class.